Today we're going to talk about graphing linear functions and also graphing vertical and horizontal lines. Let's take a look at this first equation right here, y equals mx plus b. This is known as slope-intercept form. And the reason why is because m represents the slope of a linear function, or a line, and b represents the y-intercept. An ordered pair is any point on the graph. So when we write an ordered pair, we put parentheses, and you'll see x comma y inside of the parentheses. X always comes first. The slope of a line is also called the steepness. We will also use rise over run, or change in y over change in x. In the last video, we talked about the equation y2 minus y1 over x2 minus x1 to get the slope. And keep in mind, in slope-intercept form, we look at m in order to figure out what the slope of the line is. Blank is where the function crosses the y-axis. That would be the y-intercept. Okay, we always write a y-intercept 0 comma y, or in this case 0 comma b, because if we're using slope-intercept form, it's that b value that's going to tell us where the y-intercept is located. Please note, if you are given an equation in standard form, you need to rewrite the equation in slope-intercept form to make it easier to identify the slope and the y-intercept. So if you have a function in the form ax plus by equals c, that's called standard form, and that's not very helpful for graphing a linear function. Standard form, your a and b values will be constants that are integers, and a should always be positive. Again, I don't like standard form, so if you have standard form, you're going to rewrite it, solve for y in order to easily identify the slope and the y-intercept. Here are the four types of slope that you might see. There's positive, negative, zero, and undefined. Okay. For positive, let's remember that slope is rise over run. And moving from left to right, you're going to see that the positive slope goes up or increases from left to right. Imagine that if you had a person over here on the left-hand side of your graph, you would have to hike up that hill. So that is a positive slope. Okay, let's just pick a point on that graph there. I'm going to zoom in a little bit. Let's say I pick this point. One way I can land on the same line is going up and to the right. Remember, if I go up, that's the rise, and to the right would be the run. Up is positive and to the right is positive, so I would end up getting a positive slope overall. Okay, so that's going to be up and right would give you a positive slope. Okay. Again, another option would be to go down and to the left. Remember, the rise here would be down and the run would be to the left. Down is negative, and to the left is negative. And what's a negative divided by a negative equal? That's going to be a positive. So again, down and left would also give us a positive slope for a line. Negative slopes look like this, moving from left to right. Notice the graph is decreasing or falling from left to right. Imagine I have a person up here, and he was moving from left to right. He would slide down the hill. Okay. Let's imagine picking a point on this line. What would I have to do to get to another point on the line? Again, thinking about rise over run. I could either go down and to the right. The rise would be down. The run would be right. Remember, down is negative, and to the right, that would be a positive x value. So a negative divided by a positive is a negative slope. So again, down and right. gives you a negative slope. You could also go up and left and still land on that line. Remember, the rise would be up, the run would be left. Up is positive, left is negative, and a positive divided by a negative is a negative. So again, if you go up and left, then you still get a negative slope. 0, we have a 0 slope when we see a horizontal line. Okay, imagine you're moving from left to right and you have a person here. And he just walks along the road. There's no grade. He doesn't have to hike up a hill or descend down a hill. He just walks straight forward. That's a 0 slope. Okay, again, rise over run. There would be no rise, and you can really move this way or this way. Let's just say the run is positive. 0 divided by a positive number is still going to be 0. Okay? Or if you move to the left, 0 divided by a negative number is still going to be 0. Okay? Either way, your rise over run is 0. For undefined, that's when we see a line moving up and down. Imagine you have a person over here. Can it just walk straight forward? No, it's got this wall. Can a person go whoop, up a wall? I mean, not really unless you're Spider-Man. So we like to say that this is an undefined slope or an undefined grade. Okay, so we use that when we have vertical lines. Let's think about rise over run. Okay, let's say that, again, let's say he's down here and he wants to go up. The rise would be positive, and the run, really we're not going left or right at all, it's going straight up, so that would be 0. Okay, same thing if I wanted to go down, the rise over run would be negative divided by 0. Either way, you can see that you have a number divided by 0. What does that spell? No, you can't do it. Okay, anytime you have a number divided by 0, that gives you an undefined slope. Fill in the indicated information and graph the line. Okay, in this case, we have y equals 5. Remember, we have y equals mx plus b. Another way to write this would be y equals 0x plus 5, right? 0 times anything is just 0. So really, this would be equivalent to y equals 5. So what is my slope in this case? My slope is 0, and what is my y-intercept? My y-intercept, or my b value, would end up being 5. So I'm going to write this as an ordered pair, 0, 5. Remember, when you see it in this form, that means that every point has a y value of 5. Okay, so let's graph this. We have a y-intercept of 0, 5, and the slope is 0. So it should be a horizontal line. Oops. Okay, see how every point on that line would have a y value of 5? That's what we want. Okay, slope of 0, y value of 5. This is the line y equals 5. Remember, anything in the form y equals is going to be a horizontal line, where any function in the form x equals is going to be a vertical line. Okay, so if it's just y equals a number, horizontal line. If it's x equals a number, we have a vertical line. All right, so there we go. That leads me right into example 2. X equals -4. I already know that's going to look like a vertical line. This is going to be a vertical line. Vertical lines have an undefined slope. I'm just going to put U and D. Okay, this is a vertical line. And the y-intercept here, well, let's graph it first. X equals -4. It's a vertical line through the x value, -4. Remember, x equals -4 means that every point on the line has an x value of -4. So just think about some points that would have an x value of -4. Here we have -4, 0, -4, 1, -4, 2, -4, 3, etc. Okay. Does it cross the x or the y-axis at all? Do you see anywhere where it crosses the y-axis? No, we don't. Okay, so for y-intercept, we're just going to put none. It's kind of weird. Okay, so now we get down to y equals -3x plus 2. Here, that would be similar to the form y equals mx plus b. Remember, m is your slope and b is your y-intercept. So here the slope is -3 and the y-intercept would be 2. Now, I'm not just going to write this as 2. I'm going to write it as an ordered pair, 0, 2. So I'm going to plot the point we know first. So I'm going to plot 0, 2. And we have a slope of -3. So anytime we don't have a denominator, I can either write this as -3 over 1, or I can write this as 3 over -1. See how they both still reduce to -3? So what would this mean in terms of rise over run? Here the rise is -3, so that would be down 3. And then we have a positive 1, so that would be right 1. Or we have positive 3 on top for the rise, so that would be up 3. And then my run is -1, so negative would be to the left 1. Okay, so you can do either one from that point. So let's do both. I went down 3, 1, 2, 3, right 1. Or from that same y-intercept point, I could go up 3, left 1. Either way, it should land on the same line. Now check. Does it look like you have a negative slope there? Yes, it does look like it falls from left to right. Okay, 1/2 x minus 3. Again, the slope is your m value. So that would be 1/2 in this case. I have some people that for whatever reason, write 1/2 x. That is not right. I do not want this whole thing mx. The only thing I want when you're identifying slope is just the constant m. So it's only going to be 1/2 that we write here, not 1/2 x. And then the y-intercept is going to be that b value, -3. Again, we are not going to write -3. We're going to write the ordered pair, 0, -3. So let's plot a point on the line first. I'm going to plot the 0, -3. And then from there, I'm going to use the slope for another point. Now the slope is 1/2. Again, we're thinking rise over run. So when I'm talking about rise, that would be up 1. And the run would be, because it's positive, it would be going to the right 2. So let's go up 1, right 2. Up 1, right 2. Then we can draw our line. You'll notice that we also could have gone down 1, left 2, and still landed on the line. Right? Down would be negative and left would be negative. Negative divided by negative is a positive. Ooh, and the last one is tricky. Okay. This is what we called standard form. Notice that it's not in the form y equals mx plus b. So we cannot easily identify the slope and the y-intercept. So my goal is going to be to get it in this form. We're going to have to rework this problem a little bit here to get y by itself. Okay, the first thing I'm going to do is I'm going to subtract 10x on both sides. So I would end up getting 8 minus 10x equals -2y. And then in order to get y by itself, I have to divide both sides by -2. Okay, so everything is going to be divided by -2. What is 8 divided by negative 2? That's going to be negative 4. What is negative 10 divided by negative 2? That's going to be a positive 5x. And then we would have that equal to y. Okay, so just with some reworking here, right? mx is your 5x. Then plus b, the constant is negative 4. Okay, now I can easily identify the slope and the y-intercept. The slope is 5, and the y-intercept is negative 4, which I'm going to write this as 0, negative 4. Okay. Because, well, let's first plot the y-intercept, 0, negative 4. Then I'm going to use the slope to get my next point. Because the slope is 5, I can write that as 5 over 1. And so I'm going to do rise over run. That would be up 5, 1, 2, 3, 4, 5, right 1 in order to make my next point. I could also go down 5, left 1, since a negative divided by a negative is a positive number, but that would run off my graph. So we're just going to plot the point 1, 1 and draw a line through it. You only need 2 points to draw a line. Okay, and that's it.